So welcome back to the class of nomenclature of heterocyclic chemistry. In this class, I shall discuss the nomenclature of fused heterocyclic system. In the last class, I have discussed how to name individual heterocyclic compound by adding the suitable prefix as well as suffix. So prefix gives the idea regarding the what type of heteroatom is present, and in the case of suffix gives the name ending gives the idea of size of the heterocyclic ring as well as its saturation, whether it is unsaturated or saturated. Okay, so after that one, so along with that, I have explained how to add the indicator hidden also in the nomenclature. So in this video, I'll be explaining how to name a fused heterocyclic system. So generally, the fused heterocyclic system, obviously it will be comprised of two heterocyclic system. Okay, for example, you can see here I have given is benzimidazole. Okay, so one is base component and the other one will be the attached component. So the main important thing regarding fused heterocyclic system, you can divide it into two segments. One is BC, that is a base component, and the other one is the attached component. Okay, so we need to keep in mind these two terms, BC and AC. For example, if you take benzimidazole, okay, sorry, there is a nitrogen out here. If you take benzimidazole, okay, we can depart into two segments. One is benzene and other molecule is imidazole. Okay, so imidazole, that is a base component. Okay, I'll tell you in the next slide. I will tell you what are the criteria for selecting the base component. So this is the base component and this is the attached component. So the name will be the combination of attached component plus base component. Okay, so attached component is something like a substituent for the base component. So generally, I told you the components are given their trivial names usually. If not, some of the systematic IUPAC name is used. So we shall discuss how a base component and attached component is being selected. So second point, okay, you can see the second point is base component. So base component should be a heterocyclic system, no doubt. Okay, so it is further determined by the following order of preferences. First one, nitrogen containing compound is selected as base component. The first priority should be given to the element nitrogen. Okay. In other case, remember, in other case we have explained the order of preference is O, oxygen, sulfur and nitrogen. But here for selecting the base component, the order is not this one, not this one. The actual order is nitrogen will come first. Okay, this will come first. That is nitrogen, then oxygen, then sulfur. Okay, this order is only for selecting the base component. Clear? In other case, for giving number and for giving name, etc., this was the order. So this is the common order. But when it comes to the selection of base component, the first importance is given to the nitrogen. So nitrogen containing compound should be selected as the base component. That's the first point regarding selection of base component. Okay, suppose if nitrogen is absent, then the order of preference is oxygen and sulfur. Okay, then the order of preference will be oxygen and sulfur. Clear? So like that, you can select a compound as base component and attached component. Okay. So here you can see that in the first case, you can see here there are two systems. One is pyridine as well as thiophene, but the base component, the BC base component is pyridine. This is the base component. So pyridine will be the base component. So here, because you can see there is pyrrole as well as furan, but you can see nitrogen is present in this ring, so pyrrole will be the base component. So next case, if nitrogen is absent, so if you come to this one, benzofuran, so the base component, no doubt, because the heteroatom containing ring should be the base component. So the base component is furan. So here furan will be the base component and benzene will be the attached component. And coming to this one, BC, okay, in both the case nitrogen is absent, then the next preference should be given to the oxygen than sulfur. So again here furan will be the base component and thiophene will be the attached component. So this is the criteria for selecting base component. So another criteria, suppose okay, if a component with a largest size will be the base component. Suppose here you can see that both the case same heteroatom is present. In both the ring same heteroatom is present. So in such case you can say that the component with largest ring size will be the base component. If you take this one, you can see thiophene and thiopine. So thiopine is having ring size 7, so base component is thiopine. Thia plus epine. Thiopine will be the base component. Okay. Here when it comes to this one, you can see two components. One is pyran. Okay, one is pyran and furan. But the ring size of pyran is bigger than the furan, so the base component is pyran. So pyran will be the base component and the furan will take the role of attached component. Okay, but suppose if the heterocyclic system contains same ring size, okay, rings of equal size, but with a different number of heteroatoms. Okay, in that case, a ring with greater variety of heteroatom is taken as a base component. Greater number of heteroatoms or greater variety of heteroatom will be taken as attached component. So here you can see there is a combination of pyrrole and oxazole, 1,3-oxazole. So base component will be oxazole, because oxazole, 1,3-oxazole contains two heteroatom, that is oxygen and nitrogen, whereas pyrrole contains only one heteroatom, that is nitrogen. So greater variety of heteroatom containing ring will be taken as a base component, or will be preferred as the base component. Okay. So next criteria for this one, suppose if ring of equal size, okay, both are having same ring size, and suppose equal number of different heteroatoms are present. Okay, in that case, the compound with greater variety of heteroatom will be preferred as the base component. Okay, you can see here both the case. Okay, if you take the this compound, you can see imidazole. You can see imidazole as well as oxazole. Both are having same ring size 5. Both are having two types of heteroatom. So in that case, you can say that greater variety of heteroatom. Here it's only nitrogen, but here it is nitrogen and oxygen. So what happens? Apart from imidazole, oxazole becomes the base component. Oxazole becomes the base component. Again, if you come to this one, you can see that here it is oxygen, nitrogen. Okay, it is nitrogen is given the first preference and oxygen. Next, it is nitrogen and sulfur. Okay, but the order of preference wise, oxygen comes first than the sulfur. Okay, so if you remove this nitrogen, because both contain nitrogen, so next you can, the priority wise, the order of preference will be for oxygen, because I told you in selecting the base component the order is O and S, NOS. So oxygen will come before sulfur, so oxazole will be the base component. Here oxazole will be the base component. Okay, instead of thiazole, oxazole becomes the base component. Okay, and next, suppose if rings of same size, same number of same kind of heteroatom, then the ring with the lowest locant of heteroatom is selected as the base component. You can see here both are having two heteroatoms, nitrogen each. Both are having same ring size. In that case, the ring with lowest lowest set of position of heteroatom, lowest locant of heteroatom are taken as the base component. Here you can see that it is 1 2. So it is not the oxazole. Sorry, the names are being changed. You can see that it is pyridazine and pyrazine. You can see two compound, pyridazine and pyrazine. Okay, so the base compound is pyridazine, because pyridazine, you can see it is 1 2. The nitrogen position is 1 2, whereas in the case of pyrazine it is 1 4. Okay, so the locant position is 1 2 and 1 4. So pyridazine will be the base component. Sorry, it's a mistake. Pyridazine will be the base component. If you take these two, okay, if you take imidazole and pyrazole, okay, if you take the next compound, again you can see that both the case, okay, it is 5 ring size, both contains two heteroatoms and both are nitrogen. Okay. So in that case, in the case of this one, imidazole, it is 1 3, imidazole is 1 3 1 3, whereas pyrazole it is 1 2, pyrazole is 1 2. So the base component will be pyrazole. The base compound will be pyrazole, because that is having lowest locant number, lowest set of numbers with respect to the heteroatoms. So in this case, pyrazole will be the base component and imidazole will become the attached component. Okay. So next point in selecting a base component, if there is a huge a polycyclic ring, okay, then a component with maximum ring is selected as base component. So here, if you take, you can classify it into this one. So you can take a quinoline as one segment and pyrazine as the next segment. So the base component is with 2 ring, that is a quinoline. So BC will be the base component will be the quinoline. Base component will be quinoline. Clear? So that is the criteria for selecting the base component. So next point, okay, come to the, I told you a fused heterocyclic system is divided into two parts. One is attached component and one is base component. I have explained what are the criteria for selecting the base component. So next, let us see how a attached component is being chosen and how it is being named. Okay. So generally, the attached component is added as a prefix. I told you. So generally, the name will be like this one. So name of the fused heterocyclic compound will be attached component AC plus BC. So the name of attached component is added as a prefix to the suffix base component. So usually the prefix, that is attached component, is added to the BC by changing the terminal E into O. For example, if you take pyrazole, pyrazole will become pyrazolo because E is changed into O. Similarly, thiazole will become thiazolo, thiazolo. Pyrazine will become pyrazino. But there are certain exceptions, like benzene will not become benzino. Instead of benzino, it becomes benzo. Similarly, pyrimidine will not become pyrimidino, it becomes pyrimido. So these are the certain exceptions. Similarly, naphthalene, okay, you can see naphthalene will not become naphthalino, it becomes naphtha. It becomes naphtha. And pyridine will become pyrido. Similarly, quinoline will be converted into quino. Isoquinoline will be converted into isoquino. Furan will be changed into furo, and thiophene is thieno. Imidazole will be imidazole, like that. Okay. Now, another important thing is that the bonds of next point after the selection of BC and AC, the next point is that the BC name bonds are giving alphabetized. Okay, for example, the 1 2, I can say here this is 1. Okay, the bond 1 will be this one. Okay, this is 1 1, it is 2, this is 3 4 5 and 6. Okay, the first number should be given to the heteroatom, and the bond 1 2 will give the name, the alphabet A. Okay, so here this bond will become A. This is A. Okay, 2 3 will become B. 3 4 will become C, D, E, F, like that one, and this will be F. So after selecting base component as well as attached component, next thing is that you should give alphabets for the base component. That is 1 2 bond will be given A, 2 3 will become B, like that one. Next, the attached component. Okay, the attached component, the fifth point, the AC are numbered. BC is given the alphabet. The bond of BC is given the alphabets, while the attached component are given the number 1 2 3 4 5 etc, following the lowest possible numbering, which we have explained in the last class. Now, suppose the atoms, the next point, the atoms, next point regarding the fusion nomenclature system, the atoms common to both the rings, that is fused bond, okay, is indicated by appropriate letters and numbers for the attached component and base component in a square bracket. Okay, so usually it will be done that in a square bracket you will be writing the number of the attached component and the alphabet of the base component. So this will be added in between AC and BC. So this fused bond will be indicated by a number corresponding to the attached component and a letter corresponding to the base component. Clear? So the name will be like this one. Okay, so it will be AC. Okay, attached component, the name of the attached component, and number corresponding to the fused bond of the attached component, and letter corresponding to the fused bond of the base component, and BC as the suffix. So it is AC with number 1 2 and a alphabet and BC, name of BC. So like that, the nomenclature of heterocyclic, fused heterocyclic compound does. You can take some examples. If you take some examples, you can see here I'm taking so this example, you can see two components, one is thiophene and one is furan. So based upon, I told you the order of preference is NOS. Okay, so after nitrogen the preference should be given to oxygen, so furan will become the base component and thiophene is the attached component, right? I told you for the base component we have to give the numbers. After that we have to give the alphabets. Okay, for example, I can give number 1. I can't go 2 here because ring is moving in this way. So ring is moving in this way, so it is 2, this is 3, this is 4 5. So you can, now I told you the base component should be given the alphabets. So 1 2 bond will be, this will be A, this will be A, this will be B, C, D, E, etc. Okay. Next thing is that after selecting the attached component bonds should, the atoms should give the number 1. You can go to this because now this fused bond is in this direction, so I have to go 1 2. I have to go in this way only, 2, that is anti-clockwise, 2 3 4 5, like this one. Now I can join this one. I told you attached component should come first. So it is thiophene become thieno. So thiophene become thieno. Okay, thieno. Then comes the square bracket. You can see that the bond the fused bond is 2 3. Okay, it is 1, it is 2, it is 3. So the number will be 2 comma 3 corresponding to the attached component dash. Then you have to select the fused bond for the base component, because this is A, this is A, and this is B. So it is moving in this direction. So B is the fused bond. This is the fused bond. This is the fused bond. So it is 2 3 B. Then the name of the base component, that is furan. Then you can add the suffix furan. So the name of this compound will be thieno 2,3B furan. Similarly, coming to the next example, you can see here there are two compounds. One is pyrazole and 1,3-oxazole. So I told you a greater variety of heteroatom will be the base component. So in that way, oxazole will become the base component. Okay. So in numbering this one, because I told you numbering and etc. The order of this one is OSN, and okay, don't confuse between NOS and OSN. So here the first name number, first we have to give the numbers. Okay, it is 1, base component is 1. Okay, and you cannot go this way, because it is, if you actually the fused bond is over here, fused bond is over here, but if you go in this way, if you go in this way, it will be 2 3 4. Okay, the heteroatom will get them 1 4 log n, but you should get the lowest log n. So it is 1 2 3 4 5, etc. Clear? So 5. If you write the alphabets, it will be A, this will be B, this will be C, and this will be D. The fused bond will become D. This will be E. Okay. This will be. Next thing what you have to do is we have to number the attached component. Okay, obviously this will be 1, this will be 1. Okay, actually the fused bond over here, if you go in this, if you go in this way, it will be getting this number will be getting 5. Okay, so what you have to do is instead of this one, we have to move in this way to get the lowest number 3 4 5. Okay, now we can see that the fused bond, it is D. Okay, it is D over here, and you can see that I'm writing ABC. It is moving in this direction. It is moving in this direction. So the number should be also in this direction, that is 4 and 5. Okay, so the name for this one, it is again mistake. It's not oxazole. It is imidazole. Okay, copy paste mistake. It is imidazole. Sorry, it is not imidazole. It is oxazole. Okay, it is oxazole. Okay, fine. Correct. Okay, sorry, it is oxazole itself. So the name will be attached component is pyrazole. So it becomes pyrazolo. It becomes pyrazolo. Okay, now in a square bracket. Okay, the attached component number, because it is moving, ABC is moving in this way. Okay, ABC is moving in this way, and the number corresponding to pyrazole, it is 4 and 5. So it is 4 and 5. So it is pyrazolo. Okay, pyrazolo 4 comma 5 for 5 D for 5 D oxazole. Okay, for 5 D oxazole. Okay, so name is pyrazola 4,5-D oxazole. So another example, if you take this one, you can see that here there is oxazole and as well as imidazole. Okay, same, there is oxazole as well as imidazole. So here oxazole will become the base component, because there is a variety of heteroatoms, oxygen and nitrogen, whereas in the case of imidazole there is only nitrogen, 2 nitrogens. So you can give because the fused bond is moving in this direction. Okay, so but the number, it is 1 for here, it is 1. So this is A, it is 2 3, so it is B, C, D, E, etc. Okay, and for numbering this one, this will be getting number of 1, but if you move in this way, this will get 4, but you have to go 2 3, and fused bond will become 4 and 5. Okay, so the name will be attached component is imidazole, so it is imidazole, imidazole. Okay, in square bracket. Okay, because ABCD is moving in this way, ABCD is moving in this way, so I take 4 5 imidazole 4 5 D for 5 D oxazole, oxazole, oxazole. Okay. Another example, I've taken a combination of pyridazine, okay, that is 1,2-diazine, as well as pyrazine 1,4-diazine. So the lowest locant will be the base component. So pyridazine will become the base component, and you can see here the numbering will have to be in this way. 1. Okay, this will be, this should get okay, you can take this as the 1. Okay, this as 2, because we can move in this direction. You cannot go 1 2 3 like this one, because this will be getting 1 2. So this is the best way. 3 4 5 6, etc. And you can write the bond alphabets. This is A, this is B, and this is C. This will become C. Okay, and like that one. D. Okay, so coming to the this one, this is 1, this is 1, this is 2 3 4. So it is moving in this direction. So you can see that it is in this direction. So pyrazine, you can write is pyrazino, pyrazino. Okay, alphabets, it is 2 3, because this is the fused, this is the fused bond, that is 2 3 2 3, and the fused bond is C, 2 3 C, pyridazine, pyridazine. Okay, suppose if a common heteroatom is present, it is considered to be owned by both the rings. You can see here there is a heteroatom present at this junction, in this junction. So it is owned by this, that is imidazole as well as oxazole, and oxazole will become the base component. Oxazole will become the base component. So you can write 1 2 3. So this will be A. Okay, I'm just writing the alphabets only. This is B, this is C. Okay, so it is moving in this direction, A B C. Okay, and next this one, because the indicated hydrogen should get the lowest number, so it is 1. Okay, it is 2, it is 3. So the name will be attached component is imidazole. It is imidazole, imidazole. Okay, so it is, since it is moving in this direction, you can say that it is not 1 2, because it will be 2 1, because the direction of ABC is in this direction. So the number should be 2 1. Remember, it is 2 comma 1. This is the fused bond is B, fused bond is B, and this number is 1 2 3. So this is A, so this will be in this order. Okay, so it is 2 1. Remember, it is 2 1 B oxazole, oxazole. Okay, another example, if we take the combination of pyrrole, okay, 2 pyrroles, you can see here. So I have taken this one. You can take any one as the base component. So I have taken this one as a base component. Okay, you take anything, it will be okay. So 1, okay, so because the fusion is over here, you can take it is 2, so this will be A, this will be B, C, D, etc. Coming to the attached component, the first number should be here because 1, and fusion is in this way, so it is 2, 3, 4, 5. Okay, so ABC is coming in this way, so it is you can write it is a pyrrolo. Pyrrolo will become pyrrolo. Okay, it is moving in this direction, so it is 3 2. It will be 3 2, not 2 3, it will be 3 2, 3 2 B, 3 2 B pyrrole. Okay, next point, I can say that the position of the saturated atom, that is indicated hydrogen, is generally indicated by an italic H and is given the lowest possible number. Okay, for example, if you take this compound, if you take this compound, for example, you can take pyran as well as furan as the uh, components. So pyran will become the base component, whereas furan will become the attached component. So this will be 1 2 bond is this one, so it is A, it is B, it is C. So this will be B. Okay, so it is moving in this direction. So here the number is 1 2 3. So it is 1, it is 2 3, 2 3. Okay, so what you have to do is, you can see here, this is the it is 1 2 1 2, so you can write it is 2H 2H. Okay, then you can take the attached component, that is furan, it is furo. Okay, and square bracket, it is 3 2 because it is moving in this direction. Okay, it is A here, it is A here, B here, so it is moving in this direction, so it is 3 comma 2 B pi. Okay, next, suppose if benzene ring is fused to the heterocyclic system, so generally the compound is named by replacing the number indicating by adding by placing the number indicating the position of heteroatom before the prefix benzo followed by the name of the heterocyclic compound. For example, I told you in the case of benzene fused with imidazole, it is benzimidazole. Okay. Here you can see here, you can see that it is benzo. Okay, so benzene and furan, so it is benzo. So it is A and it is B. So in the square bracket you can write benzo B furan. Benzo B furan. Similarly, this one, this will be A. Okay, this will be B and C. So it is benzo C furan. So if benzene is fused with the heterocyclic system, you can add benzo and the name of the heterocyclic compound. In between, you can add the its fused bond. Similarly, if benzene is attached with some of the other heterocyclic ring like benzimidazole, it will be benzene plus imidazole, that is benzene. Straight away, you can add benzimidazole. Okay, so suppose this one, this will be benzimidazole. This will be benzimidazole. Okay. And some other examples, if you take pyridine as well as pyrrole. Okay, so pyridine will become the base component. So this will be A. It is 1 2. I can write this bond 1 2. So this is A and this is B. So this is B, A B. So it is moving in this direction. Coming to the attached component, it is 1. It is 2, 3. So the name, the bond, fused bond is fused bond. I will be using some other color. So this will be 2 and this will be 3. This will be 3. Okay. So the name will be pyrrole, that is pyrrolo. pyrrolo square bracket, you can write it is moving in this direction. Okay, it is A here, so it is 3 2 3 2 B pyridine, 3 2 B pyridine. Okay, and next, if there is a substituent, okay, what you can do first, you just forget the substituent, you just select the base component as well as the attached component. So here thiazole will be the base component, thiazole. Okay, there is O is missing. Thiazole will be the base component. Okay. So what you can do is you can give the numbering, because numbering comes for sulfur comes first, 1 2 3. Okay, okay, 4. So if you write the alphabet, this will be A, this will be B. So the fused bond is B. This is the bond B. Okay. Coming to the attached component. Okay. You cannot give 1 over here because this is the saturated. So first number should be given to this one, 1. Okay. So there is a substituent. If you go in this way, 2 3 4, it will be 1 4. But you cannot forget the heteroatom. So the priority should be given to the heteroatom. Heteroatom should get the lowest locant. So 1 4 5. Okay. So now you mix this one. Okay, now if you mix this one, you can write it is imidazole. Okay, right now I am not using the substituent methyl. So first let us write the hetero ring, that is imidazole. Imidazole, that is attached component. Okay, so ABC is moving in this way. ABC is moving in this way. It is 2 1 imidazole. Okay, it is A here. So ABC is moving this one. Number is 1. It is 1 and 2. So it is, since it is moving in this way, it is 2 1 2 1 B thiazole. Okay. Now if you look into this molecule, the molecule I can write, okay, nitrogen. Okay, there's nitrogen out here. Methyl. Okay, this one. So you have to write number to the entire system for indicating the position of the substituent. To indicating the position of the substituent, you cannot use this substituent only for imidazole. So for that we have to number the entire molecule. That is, we can start from sulfur, because that is the for numbering, sulfur should get the first preference, 1 2 3 4. So this will be getting 5. Okay, 5 6 7. So in that way the name will be 5 methyl. Okay, so we can add the substituent 5 methyl imidazole 2,1-B thiazole. Okay, I hope it is clear to you. So that is regarding the names of fused heterocyclic compound. In the next class we shall discuss how bridged and spiral heterocyclic compounds are being named. Okay, thank you.